All right, good afternoon. So, being that I am the last person between you all and the rest of your day, drinks, prizes, and all that jazz, I won't actually take the 3 hours I just said. We'll actually try and stay on time. Yes, my title looks a little funny. It has to do with, I have this pet peeve of, we're really good about drawing diagrams that are linear, left to right. And even when we went from waterfall to Agile to DevOps, we have a tendency to stretch them out and run them left to right without much of an indication that they're actually cyclical. So I just, for whatever reason today, decided to make my talk title in a cycle. If you're a little confused about why I'm up here, you were probably expecting that guy. Originally, David Lidner was scheduled to provide this talk, but David had ankle surgery a little bit ago, and his doctor told him he's still got another month before he's cleared to travel, so I took his place today. So, should get pretty similar content. Don't quite have his panache, but needless to say. So, trying to talk about how to adapt AppSec. So, if you all probably noticed by now, the state of development's changing ever so slightly. We used to have these nice long 2-3 year cycles of waterfall, lots of requirements, lots of time. You thought you had time to test, but everyone else steals from that time, and then you end up deploying, and everything takes forever. So somebody decided a long time ago that Agile would work better. Let's just break it up, shorter iterations. And then they said, we really like this concept of breaking it up. Let's break it up even further. And let's do DevOps, let's do microservices and APIs. And the funny thing is like everybody says we do Agile. Honestly, most of them don't do the same Agile as each other. Most of the companies I go to, they have their own form of Agile where they kind of have Agile Fall or just Agile or something where they've modified or taken whatever they wanted out of Agile and made it for their own company. If you go back and look at the original documentation that the guys wrote up when they first presented the concept of Agile, very few companies I've ever worked with are actually following that exact model. Most of them have been modified. And the other interesting thing about things like microservices is if you go, does anybody know Martin Fowler? Know the name? Anyway, Martin's written a number of books, and he's about design of applications and software. He's been at it for 15 plus years now. And it's interesting where he said in the stories he's learned about microservices, almost all of the successful stories about microservices were from a mature monolith that got broken up. And almost all of his failure stories about microservices were things that were designed as microservices from the ground up. And the thing Hackman's become is microservices work really well when you have like well-defined boundaries and discrete units of work. But if you build from that from scratch, a lot of times you don't know that well enough. And then all of a sudden you keep changing and all the changes keep rippling like crazy. But we used to live in our own world. And somehow over the last 10 years, we finally realized that there are certain groups like Amazon and Google and Microsoft who actually can do data centers better than we can on our own. There's still scary elements about it, but that's where the people, like private clouds, like we can say we have a cloud, but it's our data center. So we need a better name for it. So we'll call it a private cloud. So what hasn't changed in AppSec at this point? The need for executive support. I have yet to run across an AppSec program that was successful without the executive supporting it. Without executive support, you get no budget. Without budget, you don't have people or tools or anything. And it's not just like a security executive. The other ones have to be on board as well. If the development executives or the business executives are not in favor of security, you're not going to get anywhere. You just aren't. The priority won't be made. You still need relationships. You still need governance. You still need crazy things like authentication and authorization. You still need threat models, the concept of secure design. At this point, we still write code for now. I'm I'm waiting for the next iteration. We've decided everything is now code. Infrastructure is code, security is code, configuration is code. I'm still waiting. They haven't, design as code is kind of not really there. Once you have running architecture, you can do stuff from. But I'm waiting for what's after this. What are we going to replace code with? But if you look at, I mean, these seem like boring things, but to be honest, if you could do these 8 core things in your application, and you could do them well, you would be out of 80–90% of the possible vulnerabilities in your app. If you could just do this part. And unfortunately, on paper like this, it looks relatively simple. When you start adding in all of the nuances of the technology, the framework, the business requirements, the crazy users, and all of the rest of that, this is actually quite complicated and quite difficult to pull off. And I don't say crazy users to pick on them like they're the problem. That's a different pet peeve about where security's great, developers are great, it's the users that are the problem. That's not really true. Most of the time it's our fault that users are stuck taking different paths. It's not usually the user's problem. But knowing what you have, there was an interesting tweet. I don't know if any of you noticed, but Jeremiah Grossman had tweeted this afternoon. He was talking about a previous large breach of an organization. And he was saying that he never was really satisfied with the end result where like somebody didn't patch, the company didn't patch the website, and that's how attackers got in. When he knew that they made that patch on a bunch of other sites they owned. So he went and he talked to people there, and they basically said, if we had known that app existed, we would have patched it. And it basically boiled down to, they just didn't know it was there, so they didn't know they needed to patch it. And that's where this plays in. I mean, a risk categorization where you're talking about the inherent risk of an application. Well, if you know that, you know it exists. So this actually helps contribute to having an inventory of the applications that you own. That's actually one of the more difficult things you can attempt to do, is to actually have an active and accurate catalog of what applications you actually have running. So we've done this before, doing it by just trying to do it on a relatively simple survey of multiple questions, and it pretty much tries to measure people, process, infrastructure, and what kind of data that's in there. Because when you're talking about inherent risk, this is before there's any controls, so this is irregardless. Dang it, that's not the word. Irregardless is technically not a word because, anyway, regardless of any kind of controls or any of that kind of stuff, inherent risk is just that. It is what risk does this application present before you have any kind of control in place. And so it's interesting, so that way you can help weight the applications. Because, I mean, I don't know about you, but I haven't run into anybody who has an unlimited budget to do a full-scale security level of effort in every single application that they own. They just don't. So at the end of the day, you got to figure out, what apps do I need to spend money on? Because as much as I hate to admit it as a security guy, every dollar you give me to help secure an app is a dollar you're not spending in the business to get more features, to earn more revenue, to do something else. So from a security guy's perspective, I have to be really careful what I ask you to spend money on. Because every time I ask you to put money into security, it's less money you have to do something else with. There's not some magic security money fountain that other people can't tap into. Secure design principles. I see this ignored way too often. This is the basis. I mean, I've never seen anybody be able to code their way out of a bad design. If you don't have a good, decent design for your application, you don't have controls and these concepts, these principles built into your app from a design perspective, you're going to have problems later. And they're going to be expensive problems. Because they're not findings. When you get a pen test, you have a code review, you have somebody come look at something, the stuff they'll find aren't things that are like, oh man, I totally accidentally said SHA-1 instead of SHA-256, or oh, I forgot to put TLS cert in place. It's going to be things like, you totally missed the fact that you needed an output encoding control on everything on your site. Or you totally missed like how easy it is to bypass authorization here because you didn't require the right token or you didn't require the right element. One of the big things in here that I've noticed is like psychological acceptability. And that has to do with, this is one of the Achilles heels of security right now, is usability. how many people get frustrated with actually having to follow the secure path? So humans are pattern-based. Humans follow the path of least resistance. You give them two paths to choose, and you make one a pain and the other's not so much. Which one are they going to pick? Always going to pick the easier path. And unfortunately, a lot of times, that's the path that's less secure. So you see that a lot of times. Like I'll run into a number of companies where the executives get bypasses to all the security controls because it wastes their time and costs money to make them go through all the special security stuff, when they are the greatest risk because they hold the most info, they have the most knowledge on their machines and within themselves, and they're the ones that are most inconvenienced by all these security controls we put in place. So software integrity. When I was working at Microsoft, this was a really big thing for them. Because, especially related to open source, if one of their developers inadvertently put the wrong open source into something like Excel. Excel is only about a $2 billion a year piece of software for them. So if somebody got a piece of open source, and yes, there is open source in Excel. There's open source in most Microsoft products. If somebody got a court order to make them cease and desist from being able to sell Excel, it gets expensive really fast. So from their perspective, they need to know really who put what code in that app at what point in time. And you're thinking, it's like, what's the insider threats kind of overdone at times? What are you looking at? I mean, you got things like embarrassed developers. They screwed up once, and they're rushing to sneak something in so they don't actually get caught by making a stupid mistake because they've got an overbearing boss, or they're in a competition with the other developers, and it's really tight. Dependency squatting. Remember the whole pad left? 14 lines of code, and like how many tens or hundreds of thousands of open source apps and GitHub relied on that one package? Long story, developer got into it with somebody, disagreed with it, took his toys and went home. And left that namespace wide open for anybody to claim and put whatever code they wanted to in there. And it happens a lot of times with a lot of open source projects where a company buys the project that's depended on by over 1 million other pieces of software. They sit on it for about 3 months, then they start patching it. And they patch it to add in ads, or they patch it to add in tracking. And because of our dependency management is such a massive pile of spaghetti right now, people don't notice. Because what do we tell them? You've got to do automated patching to make sure you get everything caught up to date. So you can get stuff snuck in through that. Like I mentioned, open source with unfriendly licensing, some of that stuff is nasty. I had a scenario once with unintended malicious code where a poor developer got, I don't know what he did on his machine, but he ended up getting some PHP infected on his box that he inadvertently checked into the code repository, was uploaded into the website a few weeks later, sat dormant for 6 months, and then the domain it was sent to all of a sudden woke up. And then all of a sudden, someone had leverage through this PHP form and sent 5 million spam emails leveraged off of this one nice Fortune 500 company, who all of a sudden got blacklisted in South America, and it took them a little bit to figure out why. And they're like, the developer did it on purpose. And we actually, after enough forensics, we realized the developer actually had no clue. They were just trying to check in their next piece of code for the next build, and something had gotten into it. Give you a couple examples. Going through Git, you can do code signing, SSH keys, commit signs with PGP, so you know who actually did it. There's an interesting thing with GitHub where you can squat on somebody else's previous commits that we were actually playing with as a company, where we started messing with some people who used to work there. They left, and then we would take over their account by name, not their actual account. We shut down their account, but you can actually squat on somebody's name and get credit for stuff they've done in the past. It's really interesting. Not that we did any of it on purpose outside of our own company, but you know. But I mean, there's ways to actually have that level of verification that you really know who put what in at what point in time. Like I said, this is my linear diagram. I like this one partially. If you follow check marks at all, you will see that that's technically the source of this diagram. There was a talk by Matt Rose earlier this year, early last year, where he modified it a little bit for other things. But I like it because it's one of the few graphical representations that you can follow that pretty much says the longer the delta, the larger the delta between when somebody wrote a problem in code and you actually find it, the more expensive it is. The problem is I don't have numbers for you for this. I like numbers, I like metrics, I like being able to quantify something. Nobody has done a fully vetted, decent industry survey since NIST in 2002 about the cost of fixing software defects in what stage of the life cycle. And so 2002, square in waterfall time. We have not seen it. We have no idea how long it takes in Agile or how long it takes in DevOps or what the kind of impact for that is. The thing I run into is teams are like, oh, this is irrelevant anymore. We're in Agile. We push code every 2 weeks. It doesn't matter. I'm like, that's cool. You can fix the bug in 2 weeks, but you can never return or retract the data that was lost for whatever vulnerability that got exploited in that time frame. It's just gone. You can plug the hole, but you better hope it was never exploited in that point in time. But I mean, I've seen, if you trace through and you try and find the cost, there's a number that will estimate 100-fold post-launch versus at the point of time in terms of cost, because you've got triage, you have a whole ton of people running around trying to figure out what exactly happened. Also looking at, have to do a lot of hiring because, AppSec's pretty busy right now. People seem to change jobs every 18 months now. And it's getting shorter and shorter, and there's a good chance that that's actually a legitimate concern, where the developer that wrote that issue is no longer there. No idea. But if you've ever written code and you came back to your own code 6 months later, and you're like, what on earth was I doing at this point in time? You write comments for yourself to find later because you don't know what you were thinking. So threat modeling. Anybody seen one of these before? Microsoft threat modeling tool. I have an interesting relationship with threat modeling. It's in my this hasn't changed, and it's in my this is changing at the same time. Threat modeling got stagnant for almost a decade. Nobody really did anything different. Stride is pretty decent. Unfortunately, you could probably lump everything into elevation of privileges. Like everything. If you sat down and thought about it long enough, you could put almost everything into elevation of privileges. Some people still use Dread. Please don't use Dread. Microsoft decided Dread was a bad idea like a decade ago, and they wrote it. So try not to use Dread if you can help it. Stride's okay. The problem with Stride is it's pretty heavy. The problem with most threat modeling right now is it's still quite heavy. The one on this corner is just another way of possibly doing it. But when you talk about Agile and you talk about DevOps, you don't have the time to do that. I mean, we get contracted with folks sometimes to go and sit down with the dev team for a day, the threat model, sometimes 2 days. And we can draw really cool pictures and we can get a really detailed threat model, but there's no way you can do that in every sprint. It just doesn't work. So there's other ways, and I'll talk about that in a minute. There's other concepts you can do. So what has changed? Architecture patterns. We've had talks yesterday, today, all through the year. Architectures, microservice patterns, cloud patterns, all sorts of different architecture patterns now. We took everything that we used to consider to be nice and pretty and secure within one running application instance. We decided to spread it all out, so all those internal comms that used to be between APIs and the single virtual machine are now all over the network. Be a little bit different of how you're going to handle the controls for that. Speed of development and deployment. I mean, everything is faster. So you've still got folks, and the funny thing is it's really interesting. Depending where in the world you are, depending what industry vertical you're in, you could be just now catching up to waterfall development in the original SDL that Microsoft released. You could be on the forefront of DevOps, chaos engineering, we deploy 3 times a day kind of stuff. And there's this massive spectrum right now where we're trying to figure out how to get security into this from one end to the other. Infrastructure has changed. Like we said, there's a whole lot of cloud and a lot less data center. Microsoft, when I was working there a couple of years ago, Microsoft's Azure data centers are growing, the storage demands are growing faster than their machines can rack them. Faster than they can rack multi-terabyte hard drives. The demand from the customer is growing. It's insane. They gave up trying to get humans to rack hard drives anymore because they can't rack them fast enough. So they actually had somebody build machines to pull hard drives out of a box and just jam them in racks to be able to grow the data centers fast enough. So I told you I'd come back to threat modeling a bit, but a shout out to Avi Duglin. So he's based out of Israel. He's done a lot of threat modeling work, especially within Agile. Highly recommend his talk from AppSec USA earlier this year. So within Agile, you don't have the time to do full-on threat modeling. So there are ways that you can do basically on-the-fly threat modeling at a lighter weight. So basically you try and ignore the completely obvious threats like, oh, cross-site scripting, or I have HTTP instead of HTTPS. Look at things that are more related to the business functionality of like that user story or that feature. Look at what happens if this goes wrong. Because most of the time when you're in development, it's all about how do we make this feature work? How do we make everything work? And people have a tendency not to really look at what happens if this doesn't work the way we had in mind. What happens if somebody pushes button B instead of button A? So the interesting thing with this, though, is it's something that you can do in iterations and you can do in planning, but it's not complete. But it's one of those things that grows over time. You start with a little bit and you get used to that, and then you can add the next piece and you can add the next piece, and you do it over time. One of the downsides is it's really difficult to diagram this. One of the big things that threat modeling had that people really loved was it forced somebody to actually create a diagram of how the app talks to itself, who it talks to, and how that relationship builds. There's many times that I've gone into a client and we've done threat modeling for them, and the diagram that came out of it became the official design diagram for the application because they never had one. Because almost nobody wrote those diagrams anymore. Now on the plus side for diagrams, if you're putting stuff into Azure and AWS, those infrastructures are so codified now that you can basically programmatically generate diagrams of those infrastructures and those architectures. Not so much for your own data center setup, but their infrastructure is so commoditized in that respect that it's easier to understand. So basically, you can take the user story concept as a role, I want to accomplish some goal for a particular reason. So without losing my credit card number, without losing my data, without, so add in, look at what's something that's terrible that could happen within this user story. And then go through and say, hey, what are the proper flow and failure states for this particular user story? Then look at highlighting assumptions and conditions. This is really where we've come up short for the most part, is I've done threat models, and I did one once where they had the business owner, the architect, the developer, and the sysadmin all in the same room. And I asked the business owner, I'm like, hey, tell me the business feature of what this does. And so they elaborate on what it does, and the architect's like, oh, that's not what we built. So this is, or that's not what we designed. This is what we designed. And the dev's like, that's not what we built. This is what we actually built. And the sysadmin is like, that's not what you deployed. This is what you've actually deployed. And so each of them had what they thought was based on certain assumptions and understanding of what was actually going, but it turns out that every one of them was a little off on what they thought was actually there. So just discussing them. Like, hey, what assumption are you making that would cause this to work? Oh, I'm totally assuming we would have this JWT right here. I'm totally assuming we would know this about the user. And unspoken assumptions are usually where we run into big issues with user stories. So then determine how to validate those assumptions and enforce the conditions. The things that we said should happen and need to happen for this thing to work, design into the story how to enforce that. And then explicitly handle any of the failure states. So, I mean, that's not the end-all be-all for threat modeling, unfortunately, because of how fast Agile moves nowadays. We can't do much more than that. And we'll talk about the same thing related to tooling. In tooling, there's a problem. There just is. I wish we had a solution for it. But especially, look at static analysis right now. Open source static analysis almost doesn't exist. All of the good stuff over the last 10 years or so, the people who wrote it got acquired by a company. There's almost no open source stuff. What does exist is a lot of times, to be fair, Facebook, GitHub, I think Netflix has too, they've released some level of static analysis tooling that they use. You just have to be careful of those because they didn't write them for the world. They wrote them for themselves. Then they shared it. If you align with what they're doing, it works well for you. Same thing happened with the Microsoft SDL. That was their process to build Windows. And it worked for building an operating system. It doesn't terribly align, and sometimes I get into arguments with other AppSec folks. It doesn't terribly align with building a lot of web apps or a lot of other kinds of apps. The general concepts apply, and people usually try and follow the concepts of SDL, but if you look at the meat of SDL and the detail of it, it doesn't fit for most web applications because it was a process designed to build an operating system. Similar thing with dynamic scanning, we're a little bit better. Zap's pretty good right now. Burp Suite, the 1X right now. 2X is coming. Dependency management. Dependency check is an amazing tool. Just honestly, if you're not using it, try it. Dependency track, which is I think it's a flagship project for OWASP now. That's actually a really neat way of doing stuff. Defect Dojo is pretty good in terms of defect management. So we're getting better about dependency management. The problem is dependency chains are insanely complicated right now. If you look at, you're like, hey, I have 10 dependencies, and those 10 dependencies each have 42 dependencies, and those 42 dependencies each have, and you have this explosion where you have, all of a sudden you have 500 and some odd dependencies, and most of them you never knew you were dependent on. So do you track that? Do you manage that? Is there like a list within your organization of these are approved or these are not approved type of dependencies that you can rely on? It's an interesting question. IDE plugins, and this is trying to get more toward the developer, right? So if you can tell a developer, hey, by the way, you probably don't want to do that at the point that they're coding, when they're 6th level deep, they haven't had a phone call in at least an hour and a half or a walk by to the desk, and they're in the zone and they're writing code. If they write something that's about to introduce a vulnerability, and you can actually flag it at that moment, they can fix it with essentially no cost. But if that wanders off and it takes you 6 months to find it, that's way more expensive. So there's more of a push right now to try and get IDE plugins. Some of the bigger vendors are trying to get to where you can scan your code on the fly, or you can scan it before you commit it. And that helps a little bit. DevSkim is an interesting one. It's essentially kind of a security spell check in a way. I was working at TWC when they were writing it and putting it out, and so the idea was it can work in any number of popular IDEs. You can write your own rules for it. The idea was to try and create a community that could contribute rules, and they open sourced it, and it's completely open to everyone. But the idea was to find anything that you could determine in a single line that was an oops. So if a developer wrote code and said, hey, I'm going to hash this with SHA-1, it would immediately flag it and go, hey, company policy says 256. Click here to change the method name to SHA-256. Boom, right then and there, you're done. You never introduce that kind of issue. The problem that we found is it's ridiculously hard to write those rules. Even at Microsoft, they had the worst time getting people to write rules for Roslyn. Because, I mean, they own the languages, they own the frameworks for .NET and all of that, right? So they said they had trouble paying the guys who knew the languages inside and out to write the rules for static analysis because it is so mind-numbingly hard to actually write accurate rules for that. And that's part of the reason why now I don't think we have a lot of static analysis within open source, is because it takes an incredibly smart people with a really deep level of knowledge of a language to take the time to write these rules. Now, it is for the greater good of the entire world, but that's a seriously high bar to reach, to be able to write more of those. I was going to show you this. I know you can't read that, so I do this, which you can sort of read. So I have an interesting love, mild dislike relationship with SANS. Some of the stuff they put out is really good. I'm not really crazy about how much it costs to take one of their courses right now. But this particular chart is actually really nicely laid out. And it talks about within a DevOps lifecycle between pre-commit, commit levels, acceptance, production. If you need to start exploring somewhere, or you need a starting point for some of this, it's actually a pretty nice list of different things to look at. Goes all the way into operations. Some of the stuff it covers are like cloud-related stuff. Some are container-level stuff. But because this thing can be a real pain to find at times, that's the link. That's where you find it. It's interesting. It's actually designed to be a legitimate poster. It's not a JPEG. It's not any kind of friendly file format. So it's an interesting thing to snag. The second half of it is actually really good as well about securing web applications. Gives you a nice checklist of, hey, did you put these controls in place? Hey, are you looking at this? That kind of thing. So on the concept of security tooling, so for the top 10 2017, I helped in that in terms of data analysis and collection. And there was something that was really interesting that came out of it, is in the data submitted, there was a combination of both user-generated findings from like pen test companies, and then tool-based findings. And so we broke them apart and looked at, hey, because I was curious about this. I was like, what are automated tests finding versus what are the humans finding? You know, how's this compare? And so everything on the right column are the machines, and they're basically color-coded. The more green it is, the higher percentage of the findings were actually found by machine. Where on the left column, that's for the humans. So the humans were better at, so I color-coded them orange and gray on the left as well. So the humans get the orange, machines get the gray. And if it was balanced, it's the white. So it's interesting. It found like there are certain things that automated tests are just not good at finding, that we still need humans to find. But the problem with this was frequency. So if you look at the top, machines ran over 90% of the findings. Because to be honest, if you look at the difference, when you pay a human to do a pen test, and the human finds three instances of cross-site scripting, they're like, you have a problem. But you didn't pay me to sit here for 6 months to find every instance of it, so I will tell you, you have one finding, that's a problem, here's 3 examples, here's the pattern to look for, you need to go fix it. A tool has no concept of that. It doesn't care. It will go through and find every instance of that cross-site scripting it can find. And it may give you 15,000 findings of, hey, here's 15,000 discrete points that you had cross-site scripting. So the frequency is way off when you start looking at trying to compare results between what a tool finds and what a human finds. So the numbers actually were quite nice, where I could say, hey, theoretically, if we had 10 times as many humans to do tests, we scaled humans. Humans don't scale well. But just for practice, for like academic purposes, let's say we had 10 times the humans doing the tests, and we assume that, you know, we could just scale this that way. All of a sudden, the humans are a whole lot better about finding a lot more things than the tools are. The problem is we can't really do it this way because we don't have the people to be able to run the tests. So when we finally, at the end of the day, had all the data together, and this is up in GitHub for the OWASP top 10, like if you want to look at it, it's interesting. So we had Micro Focus, which is now Fortify. If anybody didn't remember or didn't read the news, Fortify is no longer HP. It's Micro Focus. Check marks, bug crowd, number of years of error code data, synopsis. The interesting thing in here to me is not everything in green, it's everything in white. Because this is like in their entire data set of everything they found, if there's a white cell, that means they never reported that type of CWE once in their data set. Which basically means what? It's unlikely that no app, so like, for instance, I'll pick on check marks for a minute. Or I'll pick on error code because it's a better example. Security misconfiguration. In 2014 and 2015, here and here. See there's zeros up there? How many apps have you ever tested that didn't have at least one misconfiguration? Like default password, access to something. They just weren't looking. There was no test written to actually look for that and report a misconfiguration. Look in 2016, all of a sudden, almost 44% of the apps they're testing have security misconfiguration. Do you think all of a sudden those apps got changed to have 44% in that year and they didn't have it in previous years? That's incredibly unlikely. It's more likely they just didn't test. And I'm not trying to, I do not want to pick on anybody in this because I have the utmost respect for each of these companies for being willing to actually contribute the data. And that is like, we need more of that because without being able to share that data out, be able to share those stories, we'll never get better at this. I mean, you can see in general, like insufficient security logging, not one of them. That may change in the next few years because it's in the top 10 now. So to say you're top 10 compliant, you're going to have to check. So I'm really curious to see what kind of tests actually come out of that, to see what kind of tests we can do for insufficient security logging. So what can all that data tell us now? It's like humans are still a whole lot better about finding diverse vulnerabilities. The common stuff that you can regularly find, tools find. And they can be good at finding that. And they don't tire out. They just keep going. They don't require caffeine. They don't require sleep. They don't require time to work out. So tools work well for that stuff. But tools only find what somebody told them to look for. And only in certain particular scenarios. They're fairly limited at this point. So tools can scale really well, but only finding a subset of vulnerabilities and issues within your apps. So honestly, you need both. And like I mentioned, with all the white zeros in there, we're not looking for everything yet. So on one hand, we absolutely need to integrate security testing into automation. We absolutely have to get in there. But don't go in there with the expectation that the tools will find everything. Because they just simply can't at this point. You still need that human element. I mean, create, I'm not going to read the slide to you, but create stuff with early detection. The earlier you find stuff, the better. Understand when a vulnerability got introduced into your app, because that makes all the difference in the world for how to actually address that root cause. Was it a new developer who has not been through security training? Was it the fact that we started with a new language and framework that we don't have a control for? Do we have no guidance on something? So it's interesting because like when you talk about testing for security, if you can put something in place where you have a relatively known set of languages and frameworks, and you have a team that can build known controls. So you have like known authentication controls, known input validation controls, known output encoding controls. It's far easier to test for the existence of that control than it is to test for the existence of an issue. Because the existence of a control is like, that is known. You can say, hey, did you use this language framework, Java Spring, did you use this method? If no, then I can flag that, because I know this is by policy what you're supposed to be using in this scenario. Now, if you want to say, hey, did this data get from user input to the database untainted? That's a ridiculously difficult problem to solve and to accurately test for. I mean, even today, static analysis tools are, in my experience, they're somewhere in the neighborhood of still 60, 70, 80% false positives. Because they have to err on the side of caution, where they're like, this might be a problem, but we don't know enough to actually tell you if it is for sure or not, so you have to triage it. And that's painful when you get developers get lit up with, you get all the nice integrations in the Jira, you dump things automatically, and you pat yourself on the back, thumbs up. You run it the first time, and the dev team is faced with 30,000 JIRA findings. And they're like, yeah, nope, we're just going to turn that off. It's not going to happen. So figuring out how to start small. Start with things you know you can look for. And also understand when you're doing the testing, know what style of testing can find what type of vulnerability. For instance, I was working with a client, and we were helping them implement both static and dynamic testing. And both were looking for insecure headers, essentially either the existence of certain security headers or the existence of certain headers you shouldn't have that disclose information about your infrastructure and so on. In dynamic analysis, it's pretty darn accurate because it can look at the response. And at the end of the day, after the response comes back from the app through whatever proxies, firewalls, and whatever stuff is between you and the tester and the app, it knows, delivered to the browser, what headers there are there or not. So your test is fairly accurate. Static analysis will be like, hey, I have a rule that says you didn't explicitly say all headers are HTTP only in this configuration file, flag. Unfortunately, there are a dozen places you could set HTTP only, and a bunch of them aren't actually in the application's code. You can do it on an outbound proxy, or a firewall, or something that has no relation to the application itself other than it's in its outbound flow. So there's certain kinds of things like header-related stuff that I advise people don't even look for it in static analysis, because the chances that you're right are really small, because that's much more something that you can accurately find in a dynamic analysis. Because in that, I mean, you have the actual test of the actual response that gets back to the user, so you know. But I was trying to find a transition slide to go from tooling to process. And I started thinking, I ran into this, I was like, you know, this is actually fairly descriptive of developers and AppSec some days, where you feel like you're trying to go in opposite directions, and you're not really contributing to each other. So this is quite common, unfortunately. We'll see this. You have your SDLC, and the developers do their thing, and security comes along and goes, hey, you need to do security too. And by the way, we have this cool process we gave you, and you can create your new outputs here, and here's your new tools you can run. And I'm sorry, but developers don't take well to that. Because developers, at the end of the day, are paid to actually get the business functionality delivered. Because that's how the company makes more money, and then they can pay the developers. We don't do ourselves or the developers any favor when we keep trying to create separate processes. So you run into things like, they're so far apart. It's like, how often do you know what your posture is? How old is that understanding? I mean, do you just test once a year? Is that it? You know, so what happens 1 month after your test? Everything's good because, hey, we're good until the next year comes around. But this slide like pains me, but it's true. We have a tendency to think we're this unicorn. Go application security. We're totally different and more important than resiliency, than availability, than all sorts of things that there are other groups for. Sorry, that was a soapbox slide. We need to come to the table when it comes to risk or when it comes to for apps at a business level, and we're not very good at that. But we also do this to people. And this has to do with the path of least resistance. We like to put gates up in silly places and tell people you can't get past us because we're so important that, you know, unless we give you the authorization and open that gate, you can't go past. More often than not, there's a way around that because the business has to function. We can't stop the business. We have to allow them through. So one of the things we look at is trying to be like, all right, so you have an SDL. Go find the SDL that they're following. And to be honest, it's not going to be one. I've yet to work with a company that had a single software development process. Usually multiple ones. And it'll depend. It depends on the culture. It depends on the organizational structure. It depends on somebody who has a very good charisma and forceful in terms of what they can get people to sign on for and do. It's different in every company. However, if you go find what they do, go find the tools they use, go find the process they use, and then say, hey, when you do your user stories, ask these 3 questions. And just put the results into the story. change the output of the story a little bit so that when you have to write test cases to match that story or to validate that story, there's actually security in that. I've not seen it be very successful to have unique security sprints. That was an early concept within Agile. It's like, hey, we'll just let them do their thing for a while, but 1 out of every 4 sprints, we'll have a security sprint. And I've watched those, and they're like, all right, we've got feature. Oh man, we promised the customer this feature. We can't do the security sprint for authentication yet. All right, feature. And by the time you're done, when you finally let it out, the app is 3/4 of the way built, and you have no security controls. There's no authorization model. There's no authentication setup. And you've written all of this code, and they're like, we can't go back and change all of that code. Now, it's too late. We wrote all of this. Why didn't you say something before? When you look at the base design or change management or IDE level or automation within their stuff, learn how to live in their environment. The biggest thing from my perspective that I see failing between security, and it doesn't matter how modern or old we are in either case, is that relationship and collaboration. I can't tell you how many times as AppSec that they're like, are you like audit? It's like, no, we're trying to work with you. And to be fair, auditors aren't like trying to be mean. They just have a different role to play. That's just their job. They have to be that counterbalance. For AppSec, you got to work with them. You have to understand that you aren't the most important thing to them. They have a business to run. They have money to make. They have to put features out to be able to get more customers. Security's job is to figure out how can we help them do that. And to be honest, the more things we can find to help them do it easier and on schedule, the more likely they are to choose our path. If we say, hey, this would be great, but we're going to force you to create all of these extra things and the user has 12 more steps to be able to enable 2-factor, but they'll be happy because they're secure. Like, no, the users aren't going to really like that. You're going to get really bad feedback, somebody's going to tear it out, and you're going to have wasted a ton of time on something that doesn't really work. So basically, what did we learn? I mean, it's hard, but if we give up, then we lose. We simply can't. The fundamentals are critical. They're not cool, they're not flashy, they don't have good marketing terms, but the fundamentals in AppSec are absolutely critical. It doesn't really matter what architecture you've got, it doesn't matter what language or framework, there are still base fundamentals. Now there are some good languages and frameworks now that have solved a number of common problems like CSRF or cross-site scripting. And learning the strengths of each of those languages and frameworks is essential because that helps you understand what you need to focus on for developers. Understand from the vulnerabilities you find, what's a common issue with a language or a framework? I mean, you're not going to run into really deserialization issues in .NET at this point. Unless somebody introduced a very nasty library into it, the core language doesn't have the issue anymore. There's no easy button. There's no silver bullet. There's no box with blinky lights. There's no single solution that solves AppSec. I wish there was. I could go do something else. There isn't. Tools can't solve everything, but they can sure do some heavy lifting. They can get us a long ways. They can give us a good baseline. We can say, hey, we know that code getting through this process with this tooling will not have these types of issues. But it takes a bit to set that up. Every organization has different needs and requirements. I mean, and sometimes it's between companies and sometimes it's within a company. Sometimes you have to just adapt to the process. Sometimes you're totally at the mercy of maturity or lack of maturity of IT. Because you can't enforce security on process that doesn't exist. But you could potentially help create that process. I've been part of a number of times where they're like, we simply don't have a process for design review. I'm like, all right, let's create a process with design review. And hey, let's add this little bit of security into it so that you know the right questions to ask, you have the right mindset when you do it. And I can't stress the relationships enough. You know, having that relationship with the development teams, understanding the expectations, making sure they understand what's expected of you. You tell them what's expected of them. I have an entire talk that I give to developers about expectations. It's like, do you understand what's expected of you as a developer from a security point of view? And it's amazing because they're like, we're never told this stuff. If you want to tick off a developer, a really good way is to leave them alone until they're a week from production. And then you subject them to a third-party pen test. And then you go tell them, look at all this stuff that you did that you weren't supposed to do. Guess what? You never told them in the first place they weren't supposed to do that. They had no expectation. They had no knowledge that you were supposed to do that. So help them out. Make sure they understand what's expected of them from day one, so that when it comes time to do a pen test, they're not surprised. They're like, oh, I didn't realize you could stitch those kinds of things together. That's one thing. But to be totally surprised by, like, I never knew you expected me to not have an output encoding problem. That's a big problem. That's more of a process problem. But if you've got some brilliant pen testers that figure out how to chain 6 things together, great. You're at an advanced level and you have a certain level of maturity, and those things will always be found. But those are few and far between by comparison. So since I am it, I did that. So any questions? No? All right, I don't blame you. It's 4 o'clock on a Friday.